This is a Threesis of our CS289 project. For our project, we chose to take part in a Kaggle competition on San Francisco crime classification, and we also explored the portability of our model to data collected on Chicago. We had a lot of data, over 800,000 crimes in our data set. Our data had awesome spatial features, so we were able to map out the city of San Francisco using the X and Y coordinates of each crime. We can also provide cool heat maps of each crime category. With such amazing spatial features, we decided to use KNN. Unfortunately, KNN wasn't that great. We got a Kaggle rank of around 800 and a log loss near 25. This is a pretty bad score, but not so bad for the effort we put into it. We decided to take a look at the rest of our data other than X and Y coordinates. These features look pretty independent, something that we confirmed using PCA. With independent features, we decided to use naive Bayes. We implemented the naive Bayes algorithm and determined the best feature combination. We also tried Gaussian, Bernoulli, and multinomial naive Bayes models. We improved on our Kaggle score by a lot, but from the confusion matrix, you can see that the model seems to be heavily dependent on prior probabilities. For example, since 20% of the samples are theft, most of the other crimes were mispredicted as theft. In order to improve our score further, we decided to featureize the address. Our addresses aren't actually street addresses, they just refer to the block or in the intersection, which means in a data set of size 800,000, there are only roughly 2,300 unique addresses. We computed log odds for each crime category at each address. With 70 features, we decided it was time to use neural networks. Since our dataset was already heavily featureized, we felt that a single hidden layer would be sufficient. We used cross-validation to determine the number of hidden nodes. Finally, we got a color map that actually looks like a confusion matrix. And we actually got a pretty good Kaggle result. We were ranked 15 in a competition of over 7,000 entries. Our next step was to try to port our model that was trained on San Francisco crime to the city of Chicago and see how it performed. We found Chicago crime data, which categorized crime into community area rather than PD district. In order to port our San Francisco model, we needed to find new features that were city independent. Features such as address, community area, latitude, and longitude had to be dropped. Instead, we attempted to describe communities by common social statistics like median income, population density, average in male and female age, and the top occupations. We had the web scrape all these statistics from citydata.com using Python's beautiful soup library. Since we were now down to fewer features, we decided to go back to our naive Bayes model. When we tried to use these new features that were portable, our performance suffered. Other than median income, none of the additional city features improved performance. One reason could be is that our community-based features are quite interdependent. Thank you for watching our video.